How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be taking a look at another one of our fundamentals topics, and I'll go ahead and pull up the blueprint here for CCNA. We are going to be taking a look at IPv4 addressing and subnetting. Now, this is going to be a little bit of a longer video, longer form, because I've gone ahead and I've kind of broken down some of the more unique pieces to it. So we're going to talk about how the address is structured. So we're going to talk about bits, we're going to talk about bytes, we're going to talk about binary, we're going to talk about dotted decimal, and all that good stuff that goes with it. And then we're going to look at how we can use the subnet mask and determine, based off of, for example, information we get back from the business that says, hey, we need to deploy a site. It's going to be a greenfield, which means it's a new rollout. This is what we're going to be going through and doing. This is how many users are going to be at this site. And then from there, we can go and develop a subnetting scheme based off of that information. So without any further ado, let's go ahead and dive into it. This is going to be completely a whiteboard section because there's going to be a lot of me detailing out how all this stuff works and stuff like that. I'm gonna have a follow-up video after this one that we talk about, how public IP address space is used and things like that, and then go from there. So with that being said, I'm gonna go ahead and get out of the way, and I'm gonna go ahead and pull my pen tool out, and we're gonna go ahead and get started with this whole process. Now, subnetting itself is can be a little complicated when you're first getting started with it. I know when I first started learning how to subnet, it was complicated. I didn't understand how it worked. So I'm going to break it down to you in measurable terms so you can understand how everything is broken up. So IPv4 is a 32-bit address. And the way that this is built out is into 4 8-bit octets. And what ends up happening is each one of these 8 bits is broken up, is referred to as an octet, and the 4 octets make up the 32-bit address. So you can kind of say it both ways, forward and backwards, and you get to the same conclusion. Now, each octet has 8 bits. These 8 bits each have a numerical value attached to them. So I'm going to use 128, 64, 32, 16, 8, 4, 2, and 1. So if you were to add all these up, so I'm going to go from left to right, and I'm going to put the numerical value underneath of it so you can see how they add up. If you do 128 by itself, is simply going to be itself is going to be a 128. So you turn the bit on when you want to leverage it. We'll talk more about that here in just a minute. Now you get 64 and 128 is going to be a 192. And then you end up taking that value, so they go from left to right. So you add them up from left to right. So you add this direction and you subtract that direction. Okay, so add, subtract. Now, when you do this, you're taking this number, so whatever this value and this value is, this is going to be your output, or the sum of your values. Now you take the 192 and the 32, this is going to be a 224. 224 and 16 is going to be a 240. Okay, so I don't know why that does that every once in a while. 240. 240 and 8 is a 248. 248 and a 4 is a 252. A 252 and a 4 and a 2, excuse me, is a 254. 255 plus 1, or 254 plus 1 is a 255. So from left to right, that's how you will determine out your masks. So if you take this value plus 32, you get 224. 224 plus 16 is going to be 240. 240 plus 8 is 248, so on and so forth. Now, the reason why I drew it out this way is because when you look at a subnet mask, they go from left to right. You have your A range. So the class A ranges of IP addresses are going to be 255.0.0.0 is their subnet mask. Class B is 255.255.0.0. Class C is 255.255.255. Decided to freak out there for a second. .0. And then, so there technically is Class D and Class E as well. However, Class D and Class E are not used for normal addressing. So, for the sake of brevity, Class A, B, and C are what we're going to be leveraging when we go through and explain how stuff is going to work. Now, the way that you would correlate this is in order to figure out this, in order to figure out what the subnet mask is going to be, you would take these 8 bits that are available per octet. So each one of these is 8 bits. And then what you end up doing is by turning these bits here on and off will determine your subnet mask. So for example, if you want to figure out what an address space is going to be, you will, so let's say 10.1.21.171. So to figure this out, I'm going to take 10.1.21.171. And what I will do is I'll draw over here a 128, a 64, a 32, a 16, 8, 4, 2, 1. And what I will do is I will turn the bits on, whatever numbers add up to this value. This is what we're trying to figure out. So this is the decimal version of what we're trying to figure out. This is the binary. So 10, so what numbers added together would equal 10? Well, it's going to be an 8 and a 2, right? That's going to be a 10, right? So we know that that's that. So we know that 128, 64, 32, 16, 4, and 1 are going to be turned off in order to make a 10. Okay, what about the 1? What do we got to turn on in order for the 1 to be made? Well, it's going to be the 1, right? Just got to turn the 1 bit on. Now, what about 21? How do we turn that on? Well, so far we've dealt with an even number. How do we add up an odd number? Well, the same way. We figure out, okay, so what's the closest number to the number without going over? So 16 is under 21, but 32 is over 21. So therefore, we know we're going to be dealing with these bits instead. So that's an easy way to refer to it. So with that, I'm going to say that we're going to turn the 16 on. So we get 16. Now how do we get, so 21 minus 16 is 5. So how do we get 2 more bits? We need to get 5 more bits. So that means we're going to turn on the 4 and the 1. Everything else is going to be 0 across the board. And this is how you continue moving forward with that. So now we know that 128 is going to be our minimum value, so we're going to turn this one on. So now we need to figure out, okay, we have 171 and we need to take 128 from that. So how do we figure that out? Simple math would tell me that 1 is not bigger than 8, so I need to borrow from the 7, make that a 6, make that an 11. So 11 minus 8 is 3, and 6 minus 2 is 4. So we've got 43. These guys cancel each other out, so 43. So that means that I'm going to come over here. So 64 is bigger than 43, so it's obviously going to not be that bit turned on. The next one's going to be 32. 32 is smaller than 43, so that means that bit's going to get turned on. So I've got a 1 and a 32, so I'm at a 160 right now, because that's what that would equal out to, is 160. So I've got a 160, and then I need to, so now I'm at 32, I've got 11 more to go, right? So what would I do? So 16's too big for 11, so I'm going to put a 0 there. What about 8? Well, 8 goes into 11 one time. 4, I got 3 left, so 4 is bigger than 3, so that's going to be a 0 there. But I've got a 3, so a 2 goes into 3 once, and a 1 goes into 1 once. So that is my this is my binary version of what that address is going to look like. And that is basically how you figure out your subnets. You go through and you break them down. So I'm teaching you how this works from the basics, understanding binary and dotted decimal correlation. How do you figure out what the dotted decimal will be? So the reason why this is important is because as soon as you understand this correlation, and then you understand how the bits get turned on and off on a per octet basis, and then we'll talk about this here in just a minute on how you can use basically the 17th bit through the 30th bit to figure out what size subnet mask you're going to use based off of users. So once you understand this piece, and hopefully you do, hopefully that made sense. Once you understand that piece, then understanding how the subnet mask is also figured out the exact same way. You're coming up to the exact same conclusion. So now that we understand how to take the IP address per octet, whatever that numerical value is, and then convert it to binary. I keep saying decimal. Convert the dotted decimal address output to a binary value. You do the exact same thing with the subnet mask. The only difference is we're not trying to take this because we already know it's going to be all 8 bits turned on. And then this one here, no bits are turned on because there's no, you got a 0 there. If this was anything other than 0, and just for clarity's sake, when you are doing this, whatever values you come up with here, and across the board here, whatever that number equals out to, so essentially anything in this row of information right here, this right here is going to be how you would update this later on. And we'll talk about that here in just a little bit when we get down to how would you take a /24 and break that down into smaller chunks. So that's what we're going to take a look at next. So now that we understand that piece, my next thing to talk about is how would you figure out what the subnet mask is for a particular address block or IP address. Or somebody comes to you and says, hey, I have this /16 address block. So let's say, for example, someone has handed you the 10.254.0.0/16, right? So you've got this whole /16. So you've got a /16 available to you. How do you break that up? Well, there might be justification for that. We'll talk about how big that actually is. Because at first glance you might say, it sounds big, or it could sound small if you don't really know what you're looking at. So by the time we're done with this video, you'll be able to figure that out on your own. The key factor here is a /16 is 255 /24s. I'll go ahead and just throw that out there right away. But for the sake of argument, let's go ahead and take a look at what that's actually going to look like. So the next thing we're going to go do is I'm going to help you understand the breakdown for this. So I'm going to go actually and clear the screen. I'm going to pause the video, and what I'm going to do from the right to the left is I'm going to write out what the slash notation is going to look like, and all the breakdowns for that, what that's going to look like, what the actual the mask would look like, and I'm going to do the Class B and Class C range. So the second and third octets are going to be the ones, or I should say the third and fourth octets. I'm going to focus on the low order bits, and actually let me talk about that real briefly. When I talk about high order versus low order, I'm always talking about high order is going to be 128, that's a horrible 8, 64, 32, 16, 8, 4, 2, 1. So when I say the high order bit, I'm referring to this, the higher number. When I say a low order bit, I'm talking about a 1 or something lower number. So if somebody says the high order bit for something, always think bigger number. Okay, just so everybody's clear on that. So I'm going to go ahead and pause. I'm going to draw this out for you, and then I'm going to come back. When I come back into the video, I'm going to explain what that does and then how you can come up with that in a couple of different examples. So I'll be right back. All right, so I have laid out the list at the top, and I'm going to walk you through how it's written out. But I figured I would pause the video, write it out, and then bring you guys back in. That would be better than trying to edit it later. So essentially what my goal is here with this is to walk you guys through how you would come up with a particular subnet mask based off of an address scheme that you've been given. So when we talk about this, there is some specifics that you have to remember. Remember that the same logic that we used in order to figure out the IP address of a particular the binary equivalent to a dotted decimal output, so 10.1.21.171, we figured out the binary equivalent to that. So if you can do that, you can do the exact same thing with the subnet mask, which technically is the more specific thing that I wanted to show you guys in this video. But one way or the other, you still got to know how it works. So in most cases, and I'll be honest with you, most cases you guys are going to work from this side over, because you're going to be breaking down /24s into shorter matches, or I should take that back, longer matches. A shorter match means that the subnet mask is shorter. The numerical value is lower. Where if a longer match is always going to be the subnet mask is always longer or higher. So always think that high order bit means larger address block. Tens of thousands of users, if not more. A longer match is always going to mean a fewer amount of endpoints or usable IP addresses and stuff like that. So now when we talk about that, I'm going to go ahead and back that out a little bit. When we talk about this, we have to understand that the same method, right, figure out the 128, 64, 32, 16, 8421, once we have that laid out, we can then figure out what the subnet mask is going to be. So because ironically, the way that you would look at this is on a /24, this right here, from this side over, once you have figured out your bit placement. Am I 192? Am I 224? Am I a 240? Whatever that numerical value is above it for the bit placement. So again, the 128, 64, 32, 16, 8, 4, 2, 1, right? I went to here. Basically, I did a /18 through a /30. But if you can normalize that, if you come up and say, okay, and it's going to be based off end users. It's very, very, very easy to figure out once you know how many users are going to be there, which is one of the reasons why you're going to hear me talk about once you know how many end users are going to be needed, so you can figure out it site-wide, there's going to be 3,000 people that work at this location. Okay, well, simple math would tell me that 3,000 is bigger than 2048, but smaller than 4096. So I'm going to have to go with the /20 range. Simple math, right? So then I could take that down. I could take a /20 that encompasses all the users that are going to be at my site, and then I can go ahead and start divvying that out and say, okay, well, if I know that, then I can go ahead and figure out everything else. And ironically, when we take a look at that, so we know that from a numeric value, that once we know what that value is, and for the sake of argument, I'm going to, up here, I'm going to put a 128, or sorry, /18, so this is going to be, so a /17, and then a /16, right? That's a horrible 6. So I know this is hard to read, so I'm going to go ahead and get out of the way so that you can see it better. But essentially, what this is going to equal out to is this. Actually, I'll take this back. Let me go make this slash 17. Let me move this over here because this is actually comes into play. The slash 17, this is going to be your 128. The 18 is going to be your 64. Your 19 is going to be your 32. Your 20 is going to be your 16. Your 21 is going to be your 8. Your 22 is going to be your 4. Your 23 is going to be your 2. And your 24 is going to be your 1. Now the reason why I did that is because I can go through and I'm going to explain this from left to right so that it makes more sense as we're going along, because I'm talking bigger address space. So we're thinking from the perspective of a very large site. So somebody tells you 3,000 users. I know I'm going to have to go with this. So I'm going to slash 20, whatever that address space is. So what I'm going to do, and this is where it becomes very, very easy once it clicks for you, and hopefully it will soon. If I start off with 254. 10.254.0.0/20 is the address range that I've been given. Okay, which means that slash 20, that automatically tells me information. Just having this information right here alone automatically gives me a lot of indications as to what's going on. So then all I have to do is then go to a calculator or do some basic math in my head based off of understanding how the bit placement in the octet, what that's going to equal out to. I know a slash 20 is going to be a 16 in the third octet. What that tells me is that when I go to figure this out, this is also my range for my subnets. What do you mean by my range? Well, a slash 20 is 16 slash 24s, which means when I figure this out, and let me go ahead and clear this little piece off because this will come into play here in just a second for clarity's sake. When I talk about my range of addressing, so you start off with the base subnet, right? 0.0. And then I know 16 because it's a slash 20 range. Well, that's simple then, because then I know my range is going to be through 10.254.15.255. Let me clear that up a little bit just because I don't like how the 5s weren't writing out correctly. That's going to be my range. And how I know that is because, and I'll talk a little bit about this more here in just a minute once I write this out a couple times. The 16 is going to be right here in the next range. And then what's 16 plus 16? 32. What's 16 plus 32? 48. What is 48 plus 16? 64. So I've got the first 5 subnets figured out of the gate. As soon as you tell me how many users are going to be there, and I equate that to a total, so I know it's going to be a slash 20 is 4096. It's a slash 16, or I'm sorry, slash 20. It's the 16th. It's the 16 value in the 5th bit. So 4th bit. Sorry, the 4th bit in the mask that tells me everything I need to know. I can figure out everything from there. So that's where that comes into play. So my next one's going to be through. I'm going to put it here is going to be 31.255, and then this one here will be 32 through 47.255. Now I'll talk a little bit more about how this comes into play as we get into it, because you might be having a hard time visualizing it. So you might be like, everybody gets hung up right here. How did I come up with that number? Well, the simple answer to that is you subtract 1 from this value. So if I go down 1 IP address, what's that range? Well, it's going to be, I have to drop down to the 15th subnet in the third octet and the 255th IP in the last octet, because you can't go above 255. That's numerically, that's as high as an 8-bit octet works, right? So now that I have that figured out, then I can go ahead and do the same thing over here, except for instead of doing it in this range, I'm doing it in this range over here. So now, let's say for example that I have everything mapped out. So we'll go, this is going to be 63.255, and then .0, this will be 64.0, then this will be 127.255. Well, I didn't actually take that. Oh, sorry, I'm thinking 64 range. My fault. So 64 and 16 is going to be 80. Then 80 and 16 is 96. 96 and 16, that should be what, 112? Yeah, 112, and it's 128. So that's essentially how you would break that out. So if you can find this, then figuring out what the end of your range is easy, right? This right here, this portion of it where you're figuring out the end IP address in the subnet isn't totally relevant. You could go to an online calculator and it can tell you the exact same thing. But if you can figure out a /20 as 16, you know 16 is going to be your range. Therefore, you're going to have 16 /24s. And so, or I'm sorry, you're going to have /20 is going to be your range. Technically, that is correct. So it's going to be 16 /24s is what that will equate to per block. So out of your you could have taken it as far as you like, but that's essentially where it's going to go. So now, for clarity's sake, since you've been given a /20 out of this 254, what your actual usable address range is this. Go ahead and just erase all this real quick. So your actual usable range is just those 16 /24s, because you've only been given a /20, so it's 16 /24s. So you've got 16 /24s to work with. So that's what we get to do. So now that we figured that out, and now that we know that, I was just showing you if you want to continue down and go to the left, you could go 32 would be, you'd have 32 /24s. If you went to a /18, you'd have 64 /24s, so on and so forth. Now that that piece has been laid out, the next piece to understand is, we're just moving, instead of focusing on this part, the third octet, we're going to focus on the fourth octet. The exact same thing. If I come to you and say, okay, how many we'll start off with something that's not going to be very moving very much. That's going to be the servers. How many servers are we going to have? Well, you might say, I'm going to have 40 servers that we're going to deploy. Okay. Once you have a numeric value, you can very easily attach that to a binary bit in the octet and then figure it out. So 40 is bigger than 32, but smaller than 64. So that's what we have to go with. So then you have to pick a subnet. So I'm going to pick the 0net. I'm going to say, okay, actually, I take that back. I'm going to go 15 because it's the end of the range. I like things that aren't going to be moving around a lot, I like to pick at the end. So one rule of thumb that I have whenever I'm coming up with an addressing scheme is anything that's going to be pretty static in the environment, like point-to-point subnets connecting a router to another router. Anything that's infrastructure connecting that is not going to move around a lot, I prefer to take the very end of that address and then break it down. So I'll use 1054.15 as my range for that, and I try to stay at the very end of that subnet. So I'll work my way backwards as point to points. And the reason for that is I can figure out what all the connectivity is going to look like, and then I can say I'm going to need, and this you'll have to refer to a diagram and things like that to try to get the estimation on that. But you will be able to figure out, okay, I'm going to need 8 /30s. So you figure out how many /30s you're going to need, and then you're going to start pulling those out of you're going to start allocating them in a spreadsheet. This will all be put into a spreadsheet, and then from there you'll divvy that information out to whoever you're working with, and that'll be the subnetting scheme you're going to work with. So an example of that would look like this. Let's draw out a very basic example topology over here. So we're going to have a this thing wants to act up on me. So we're going to have okay. Now that we've got that back, every once in a while it wants to, oh, I see what happened. It wants to act up on me. If I switch between the camera and whatnot, it acts up on me. So if we have R1, let's draw a circle. Let me pause and figure. Okay, after I played with it for a little bit, we're going to draw out R1, we're going to draw R2, we're going to draw switch 1, switch 2, switch 3, switch 4, and switch 5. Then we're going to draw all these guys connected to each other like so. And then we're going to draw, I'll draw I here for internet, I up here for internet, and then we'll draw M here for MPLS. So we're going to have 1, 2, 3, 4, 5, 6/30s, some point-to-points. So I'm going to need 6/30s, 6 of them for these point-to-point links. Then down here, remember from when I talked about the collapsed core, where everything northbound of this is going to be layer 3, and everything downstream is going to be layer 2. So that means between this link here and this link here, I'm also going to need additional. So let's scratch that. It's going to be at least another 8/30s for point-to-point links. So, and then the question is, how many subnets am I going to need? Well, another question that I get on a regular basis is, if I've got a /20 and I have 16/24s, do I need to allocate everything? No, you don't. That's just what you've been given. It might be even too big. But, you've got 3,000 users, so you're going to have to divvy that out. So here's the interesting thing. I'm assuming just one location. But let's say you've got 4 locations, and they're all built just like this, where you've got routers connecting to the internet and stuff like that. And you might even have some inter-switch or inter-router communication between buildings. So I'm just trying to keep it simple for diagramming sake. But let's say, for example, you have something that's a little bit more involved. Let's say you have another location. It's over here. You've got R3, R4. You've got switch 6, switch 7. Then you've got switch 8, switch 9, switch 10, switch 11, and then you've got internet, MPLS, and internet, and you have all these connections going out. And then let's say these guys are interconnected, these guys are interconnected, these guys are interconnected, and then you want to be able to, between your buildings, you want to be able to connect to these. So R1 will connect to R2 or R3, R2 will connect to R4. You have a crisscross. So then you still have to add up all these /20, all these /30s. So you might end up having 30/30s. Well, is that hard? No, it's not. You just have to figure out what all the connectivity is going to be, and then just start assigning subnets to them. So if you do enough planning ahead of time, and with the addressing scheme, you kind of just lay it all out, so you have everything figured out. Once you do, then things are much easier to work with. So again, I try to focus on infrastructure components first. Let's get all the point-to-point connectivity, all the /30s that I'm going to need out of the way. You might not even use /30s. You might go with a different design where you don't go with point-to-points. You do with a VLAN and you use /29s and HSRP. All kinds of different scenarios. Like I said, there's not a one-size-fits-all type of network design. You have all of these different ideas, and people have different opinions on things. So at the end of the day, it's just a matter of, okay, what makes the most sense? So then you have a conversation about that and then move forward with it. So, but you're going to pick at least one /24 that's going to be for infrastructure. So for the sake of ease, and I'm going to go ahead and pause real quick and erase this. So for the sake of brevity, I'm going to say that it's going to be 8/30s. It's going to be a single building. All the users are going to be inside of one building. It's going to be a bigger building. But regardless or not, you're going to have, plenty of access switches. You're going to have a distribution block. You're going to have, whatever connectivity. All that piece is 100% irrelevant for the conversation. I just wanted to give you a high-level design perspective on how you would want to approach that. So just remember, I won't even say best practice. A rule of thumb that I follow is grab the subnet at the very end of the range and use that for your infrastructure connectivity. So that could be server IPs, that could be point-to-point connectivity, whatever it's going to be that's not going to be moving around. Use the last subnet or whatever to get the job done. Okay. So now the next thing we're going to go through and do. So now we have that out of the way. So I'm going to put down here infra. Oh, we had this problem again. So I'm just going to put an I down here. For some reason, infra is going to be 15. Yeah, see, my thing is goofing up again. So I'm going to just do that. So then, to follow on from there, the next piece would be, okay, what are all the different VLANs I'm going to be needing? And how many users per VLAN? So if you think about it, you've got 3,000 users, you're going to have some sizable subnets. Or if you're smart about it, you're going to break that up into so 3,000 users probably isn't going to be a single building. Let's be real. It's probably going to be multiple buildings. And in that case there, you're going to need, a lot of floor space, right? So what I would probably do is I would end up having it broken down into /24s per floor or /23s per floor. Because, that's a sizable subnet, but just imagine if you've got, and we'll do it based off of, we got 3,000 users, we'll do 1,000 people per building. So we're going to have 3 buildings, 1,000 users per building. And then we're going to make the math very, very simple for us. We're going to say that each building has 4 floors. So that means 1,000 users, we're going to be able to put 250 users per floor. That makes our math that much simpler because I'm sitting there thinking like, okay, how am I going to break this up and make it manageable? So we have 4 floors. Again, I'm building the use case to make my job easier. So the simple answer to this would be what? We're going to go ahead and just assign /24s to everything. So how would that look? Well, we're going to go ahead and we're going to say, so for building 1, for floor 1, we're going to use, so building 1, floor 1, we're going to use 10.254.0.0/24. And then we're going to, you know what? No, I'll go with that. I was going to try to make it more specific, but that's okay. Building 1, floor 2 will be 2.0/24. Floor 3 will be 3.0/24. And then building 4, 4.0/24. Actually, I think I might have found an error in my logic there because I can't use all /16s. I'm sorry, /24s. Actually, let me circle back and we'll adjust this briefly. So we'll say 3 floors. 3 floors of 300-ish. So that'll still get us where we want to be. So building 1, floor 1, 2, 3, then building 2, and then building 3. So, because each one's going to have, I'll leave 100 IPs available or left over for infrastructure connectivity and server IPs, access point IPs, printer IPs, things that aren't going to, access point IPs, things like that. So what I'll do is, and I'll put, actually, let me pull this out real quick. And then for this one here, I'll put infra and what that subnet's going to be. So this one here will be 10.254.0.0/, we're looking at 300. So I'm going to automatically, I'll say 24, even though the math doesn't work out, right? It's going to be 255, 300-ish. So let's say that we're allocating for that, which means I'm going to have to make it this a /23. Because if you do that, you need 500 plus users. So this will be 10.254.2.0/23. So that's technically 4 subnets right there. That's 4 /24s. That gets that job done. So then I'm on 10.254.4.0/23. So I'm at 6 /24s. So I've burned through a third of my addressing space already. And as you can see, it continues to get more and more complicated as you go along. So I'm trying to, break it up. So and what you would do is you would take that 15 dot, what did that happen? That 15.0/24 that's used for infrastructure, and maybe you're allocating a /32, or I'm sorry, a /27. So /27 of 15, bring that back, 15.0/27. So you end up giving that, and you can take a /27 and break that down as far as you'd like. So that's how you would go about doing it. Now, I'm not going to go any further than that because you get the picture, right? We're allocating subnets based off of the amount of users. So 300 users in a floor, completely feasible. I've worked with customers that have several hundred, 300, 400, 500 users per floor, and the job gets done. They're in a /22 or /23. So, or you can break it up per, you might have individual rooms or departments per floor, and you break it up by department. The bottom line here is, when you are trying to come up with your addressing scheme, it may not be as super simple as what I'm trying to portray it as. It might be more complicated. But that's going to be your job as the engineer and architect to figure those things out. So that's where that comes into play. So now what I'm going to go do is I'm going to walk you guys through. I'm going to go ahead and pause. We're going to erase the bottom half of the screen, keeping the top half in place. And I'm going to walk you through how you would take a /24 and break it into multiple subnets, and then how you would figure out the subnet mask and the beginning and end range. Okay, so we're going to grab a address. So we're going to grab 10.254.0.0/24. And I need to break this subnet up into, I need to use all 255 IPs because it's the only subnet I got left. Right, we got to figure something out. Let me actually go ahead and get out of the way so we have more real estate. So what I'm going to go do is we're going to break this up. So I'm going to do a few of them. I'm going to start from my left and work to my right. So we can totally come up with 8 subnets. 1, 2, 3, 4, 5, 6. We'll come up with 6. So we have a user base of 120 users. We have, of those 120 users, we'll say half of them, 60, need Wi-Fi to be flexible. We're going to have a number of printers, so we're going to say we have 28 printers. We're going to say we have, we got 28, so it's 32, and we're going to say we have 12 mobile devices like iPads, and we have some other random stuff. We have some scanners or whatever. We have 6 scanners and whatever else we need. So let's add that up. So we have, the way you would break that down, so here we have a point-to-point. We have an external connection to the outside world. So we have we have our point-to-point link that we're going to need. So the way you would figure this out is you would always start from the top down. So I know I mentioned just a moment ago when I talked about the point-to-point infrastructure connectivity, you would figure those subnets out first and then lay those out because those aren't going to change. I would still recommend you do that for infrastructure connectivity, but on a larger scale site. But in the event that you don't have that, you can kind of omit it from your design, or it can be still at the end of the range. You'd figure that out first, and so that's an easy answer. So if you know you only have one point-to-point link, for whatever reason you only have one point-to-point link, well, it's simple. You would simply take 256 minus 4 is going to be 252. So 252 through 256, that's going to be your answer. So that's going to be the range you use. So 253, 254. That would be your, or in this case, it would be probably 253, 254, because you can't use 255. The reason I went with 256 is because that is what, from a numerical value, what you would end up using for a range. So you figure the last end, the very end of it is going to be that. So you'd use 253, 254. So as your IP addresses. So, but I'm going to go ahead and get out of the way, and we're going to walk through how we would do this. So the simple answer is this. So we know a 120 is going to fall underneath the 128. So what I would do is 128. I know my mask is going to be 255.255.255. I know that's already the case because I'm already talking about breaking the /24 down. So /24 is automatically going to be the first 3 octets. So 8 and 8 and 8 is 24. So I'm already at a /24. I need to break that down into smaller, more specific matches. So a 120 falls underneath the 128. Because I know this is the case, 128, this is going to be my range. When you're in a /24, whatever the binary bit is, or the numeric value that's associated to that particular binary bit, is going to be your range. So I know it's going to be a 128. So I'm going to have that done. So, which is also going to be a /25. Now, this is going to be the 120. I'm not going to write them all out the same, but so this one here, this will be a 128. Now, the 60 is going to be interesting because now that we've got the 128 here, now I have to be cognizant of that. So my range for that subnet is actually going to be 10.254.0.0. So it's going to be that through 10.254.0.127. That's my range. Because 127, remember my range is 128, so my next one would be, logically, would be 128 here. So that's how you take /24 and break it down into 2 subnets, 2 /25s. That's how you would do that. So my next range is going to be, it's going to start off at 128 in the 4th octet. But now I have a 60, right? My 60 is going to come into play. So 64. So what I'm going to do is I'm going to take 64 and add it to 128. So 128 and 64 is going to be a 192. So this is going to be a 128. This will be a 192. So in my subnet mask for this guy right here will be a 192 for the 60. So then I have that. So then 128, so 64 and 128 is going to be 192. So my range is going to be a 190. We'll take that back. This will be a 10.254.0.191. So my next range is going to be a 192. So 28 comes underneath 32. 32 plus 192 is going to be a 224 for my 28. So that's going to be that range. So it's going to be 10.254.0.223. And then 224 will be my next range through, and so this would be 12, so this will be a 10.254.0.239. And then this one here will be 240, 10.254.0.247. And then we have a 248 through a 10.254.0.251. And notice how I did my math. 252. You can't use 252 because that's going to be the base subnet. Right? Can't use the base subnet IP. And you can't use the broadcast, which would be 255. So you got 253 and 254. Those would be the 2 usable IP addresses on that segment. So that's how that would come into play. So, and then that would go through 10.254.0.255. 53 and 54 would be used. So you see how that comes into play. So that's essentially what you would need to know in order for this to all correlate and come together for you. Now, that's the easy part, right? We've associated our subnets, and we know that if we continue going over here, that we'd have a 240, we'd have a 248, and a 252 across the board. So that's essentially how you would end up figuring out the subnetting for all of that. So I know that could be a little challenging to read and a little bit challenging to understand the first time you go through it, but I promise you that if you take your time with it and you thoroughly understand what's happening, the subnetting piece is actually very, very easy to follow and to get done. So you're not going to do a lot of this, I promise you, unless you work for a very dynamic environment. You're dealing with this type of stuff on a regular basis. There's calculators for this, and I bet you if you work for any size organization that's got any level of organization to it, there's probably already a spreadsheet or some sort of IP address management and IPAM capability, like a Blue Cat or a Infoblox or something like that, that's already in place, or like I said, a spreadsheet that people will use in order to get the job done when it comes to IP address management. So, but knowing how to do this is important for anyone taking an exam, and you need to know how to subnet. So whenever I sit down for a Cisco exam and I know there's going to be subnetting for it, I automatically I'll write this out, because there's like I take my exams at a Pearson VUE location. So whenever I sit down, they give you like a laminated piece of paper and then an erasable marker, and I will literally I'll flip it landscape, and then I will write all of this information out, so, /20 through /30, and I'll just scribble this all out real quick so that when I'm in the exam, there's a subnetting question that pops up. And here's the funny thing about that. When you're CCNA level and you're just getting into networking, for some reason they love throwing subnetting questions at you. At least that's what I used to see a lot of, and I would be like, oh God, more subnetting. I was good at it. I understand how to break it down, but it was like, oh, great, more subnetting. So that's why I started referencing this. The higher you get up in the certification world, CCNP, you're going to see some of it, and it's going to be a little bit more complicated. But once you get to the CCIE level and you start taking like the Encore written or the INARSI, like for example the CCIE written, I never see it. I don't see it. I don't remember it being on the service provider written, but when I recertified, but so that's just an interesting paradigm when you take a look at how it comes into play. The higher your technical level gets, and the more experience you get, the less they're going to ask you subnetting questions. They automatically assume that you know how to do it. So, which I guess is kind of a good and a bad thing, but this is essentially what I wanted you guys to know and understand when it comes down to all this and how it works. So that is going to be that. Now we've covered bits, bytes, binary, dotted decimal. We've covered all the main things. I am going to, in the next video, talk about public use and how that comes into play, and some of the different things that you're going to need to know if you ever have to use go out to a service provider and set up a BGP peering for a customer, or you need to go advertise BGP to the real world and understand how RADB works and ARIN, and then do a transfer of ownership for a subnet and what the minimums are, all that kind of stuff. I'm actually kind of looking forward to that because it's something that I spent quite a bit of time working with throughout my career. So anyway, that is all I have for you in this video. If you have any comments, questions, concerns, feedback, please drop a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.